Hi roboticists, we're going to continue today our series in OpenCV Basics for Robotics. And today we are gonna learn how to make the edge detection, or better, how to use the edge detection algorithm from OpenCV to identify where the object that we want to pick is. So, before to start, make sure to subscribe to the channel, hit the notification bell, put a comment down below if you want to have to share your opinion on this series in OpenCV for Robotics. And if you want to have a deep dive into learn robotics with ROS, let's check my courses for beginner, and it will be a good starting point that will allow you to get as fast as possible from beginner into an intermediate level. So now let's get started. So first of all, open a new terminal and open Visual Studio Code in the package that we have created. Okay, last time, if you remember, we have learned how to filter an object of our image based on the color. And we are going to take this this as a template, I will say. So first of all, just create another file and call it edge detection. Okay, so as always, put the interpreter and the libraries that we will need. Now put our main section. Okay, we have created our main section where we are gonna create an object that is instantiated from the class object detection that we are gonna create just now. And we have initialized the node, giving it a name, object detection. So up to now, nothing new. Okay, now let's create the class object detection. Let's create our constructor here. So I repeat that in our construction we need to instantiate a subscriber that subscribe to the topic RGB camera RGB image row, and this topic is of type image. If you don't remember what kind of image it is, I'm gonna put the link in the description down below. So you can check what kind of data we need to deal with. And now we need to create the function that is the callback function that is taking this image object, and we are gonna make something. And in this particular case, what we're gonna do is to draw the edge from the object that with the algorithm that we are about to write is detecting. So as always, here we need to convert the image in a way that OpenCV can process. And to do that, we're gonna use the CV Bridge package. or better, the libraries. We are gonna call the image to CV2 function, and we're gonna pass the image, so the data that is subscribing. Okay, so before to continue, let's see what the camera is seeing at the moment. Okay, so we have placed the camera here, and let's check what it will see. So to do that, for example, what we can do is to display the image that we're gonna see. So for example, let's display, I'm show, this is gonna be the original one, and we're gonna pass the CV image that in a format that OpenCV can process. Okay, so first of all, let's make this file an executable file. Okay, and since that ROS is running at the moment, and we can see here, let's see what the camera is seeing here. Just run. Okay, so here is the situation. This is what the camera actually sees. And the scope of this tutorial is to surround or better isolate the object by drawing a rectangular or the edge that surrounds the object itself. So this is the situation, the starting point, let's say. What we can do? First of all, what is the edge detection? Edge detection is a tool that OpenCV has that allows to see the edge. So when the gradient, let's say, of the color is changing rapidly, then the edge is detected. And as you can see from this image, if we run into a edge detection as it is without any differentiation, we're gonna see a lot of edge. If you think you are gonna see this object here, this square rectangular here, and also this, and also we're gonna see the rectangular one from the object that we are interested in. So the first thing that you need to know that you need to do also, very useful, is to simplify the problem as much as possible. So since that we are interested in this object, what we can do is to crop the whole image into the area that we are really interested in. So for example, we can see that here the x and y is gonna be 282 and 360, and here is gonna be 528 for 10. So basically we are gonna crop this image into this rectangle. So we will not struggle in to filter the other object that is detected by the edge detection. So let's do it and see how we can do. So for example, we can create an object that we can call cropped image. And this, for example, is gonna take the CV image that we have just created in the callback function, and what we need to do is to pass the pixel that we want to crop. So in y is gonna be 307, then 4 and 10, and then in x is gonna be 290 and 5 and 20. So feel free to challenge this data based on your image. And let's see what is the aspect of this cropped image. And here we go. The image has been cropped in the area of our interest, where we have somehow isolated our object. So it will be much easier to detect the edge detection that we're really interested in. So, a best practice to make the edge detection is first to convert the image from a color to a gray. In order to make this edge detection better and work with only one channel rather than three channels. Okay, so what we're gonna do now is to convert the image to grayscale, and to do that we're gonna use the function cvTcolor. So we're gonna create an object that we can call gray, and then this is equal to cv dot, we're gonna use as I said cvTcolor, and then we need to pass the image that we want to convert, that is going to be cropped image. Here we go, and then we are going to use a method cvColor bgr to gray. So it's pretty much intuitive, I hope. Here you go. So let's see what is the aspect of this image. And here we go, this is the original, this is the cropped, and we are gonna make a grayscale from the cropped image. So here we can see that we are gonna detect the edge from this. So let's do it. So what we can do is to create a mask using an adaptive threshold. So, mask, and we are gonna use the function adaptive threshold. We are gonna pass the image gray, and then we are gonna convert the image in a binary. So basically everything that is below a certain threshold, it will be black, and what is above that threshold, it will be white. So 255, and let's see what is the aspect of this mask. Here you go. The function adaptive threshold has detected this edge from the gray image that we have passed. So now what we need to do is to find the point where this line has been drawn. So we need to find the contour of that, and for that it will be let's say a matrix that display all the points where this edge has been detected. And to do that we are gonna use the find contours functions. So let's do it. Okay, let's find the contour. And we need to pass the mask image. Here this method belonging to the function find contours. If we want to make sample, basically it's approximates all the edges that we are gonna see. This is not the case because we are working with a simulated image, but save this function and this setup if you're gonna work with a real-time image or in a real world, I mean. Then let's see, for example, which kind of contours we are gonna see for the moment. So let's print. Okay, let's run it and see what the aspect of a contour is. Here you are. So basically, if you go with the mouse with what you detect here, basically you are gonna see that I'm overlapping with my mouse the contour that is displaying here in the terminal as an array. So this is an array that detects these contours here. Okay, so let's draw a polylines that reflect all the contours that we are seeing, and we're gonna place into the cropped image. So if you want to do that, we can write a for loop. So for CNT in contours that we have calculated just here, we are gonna draw a polylines. So cv.polylines, and we are gonna draw a polylines directly to the cropped image. We are gonna pass the CNT belonging to the matrix contour, we are gonna say that this contour is a closed object by saying that it's true. And then we need to decide of which color we want this polyline to be. And here the thickness. Let's display here. For this we won't need any more. Let's test it. And here we go. You can see that the polylines simply draw a polylines at the edge that it has detected directly on the image that we have cropped with the color here. And to do that he has to use the mask that is retrieved from the threshold starting from the gray image. Okay, I wanted to add a feature that is useful when we are working with real images. And it may happen so that if you have a lot of objects, the camera is blurring, whatever, it's better to select the image that we want to focus in by calculating the area of the image and filter and display only the object that has a particular area. So for example, we can say that if a certain area is up then I don't know 10 square millimeters, then display on as an edge detection. So let's do it. So first we can create a list that we can call open object detected. So now for each object that the contour is detected, we are going to calculate the area by using the function contour area. We need to pass the contour object, and then we can set up a threshold for the dimension of this area, and we can say that if the area is gonna be greater than 20, then what we can do is to draw a polyline, and we're gonna approximate the contour with the polylines. So and then we're gonna append to the object detected. So we can print how many objects do I detected. And we can print the object detected itself. Let's run it. Okay, you can see here that I detected one object, and this has approximate into a rectangular, and in fact now what we are gonna have is 4 points here, and the 4 points correspond to the edge, the vertex of this rectangular. So if you put the mouse on it, you are going to see that for example the the bottom right corner is gonna be the one that is displayed here, and so on and so forth. Okay, so to finish, what we can do is to display the center of the object that we have detected, or better, the rectangular where we can see that is inscribed our object that we want to pick. So to do that, what we can do is to make a for cycle in CNT, this time object detected, and now we're going to create an object that we call rectangular, that is going to be calculated from the automatically from the DCV libraries. And here is displaying the center of this object, and we can call it X center, then Y center. For X center and Y center, I mean the position in pixel of the image where the center of the object is detected. This is very important that we will use in the next video. So this is the width and the height in pixel, and this will be very useful because in the next video we are gonna use this information to make a conversion between the pixel and the real millimeters in the real world. And then we have the orientation. We are not using that, we're gonna use in the next video, but you can start to practice to see actually what result gives you to your application. So what we can do is to draw a box based on the rectangular that has been calculated from the minimum area rect function. And basically is going to create a box from this pixel here. This we need to convert into integer, so we need to use the int 0 function belonging to the NumPy libraries. And then we can put a text directly in the image where we're gonna display the position of the center in X and in Y. To do that, we're gonna use the put text. We're gonna put in the image cropped image. And basically here I need to convert in round because it's taking the pixel. I'm gonna display the X center exactly at the point where the center is detected, and then basically it's easy. You can copy and paste. Here I'm gonna select the font, the dimension, and the color, and the height. What I can do lastly is to put a circle while the center is detected. And here we go, we're gonna select the color, and if the thickness is gonna be -1, I mean that that point, that circle is gonna be bold. Okay, I think that is everything. Let's give it a try. Okay, here we go. Now you can see that the center is pointed with a circle bold, and is displayed directly from the image where is the position of the X in X. The position in X and Y, and basically is going to correspond in what you are seeing here. Okay, what I wanted to point out is that this is nothing to say with the real world, because now we are just getting the image from the camera, and we are going to display the coordinates based on the image, not in the real world. To do that is something that we are going to do in the next video, where we're gonna convert this pixel in the real millimeters. So we're gonna figure it out what is the conversion between this pixel here and the millimeters, and we are gonna check and we're gonna create a node that will tell us what will be the coordinate in x, y, z based on the object detection in the real world. So as a recap, what we did is to crop the image, convert the image from color to gray, then create a mask with a threshold, and from that we have filtered the object. We have inscribed a rectangular in the object detected that we want, and we have put some text in it. So that's all for today. Thank for your attention. If you like this video, make sure to subscribe to the channel, hit the notification bell, and check my course for beginner if you want to have a deep dive. And thank you for staying with me till the end of this video, and feel free to reach me out, and as always I'm gonna put this code into my repository, and I'm gonna leave you wishing you a good learning robotics with ROS.